Last part in lecture 3 بعد ما حكينا على limit of a function of multivariables راح نحكي على continuity. Then a function of two variables is continuous at a point AB. And هنا I recall we are studying functions of two variables, but what we are saying is available for any number of variables we want. إذا اللي تعرفوه في الكالكولس إنه if you have a function of one variable, we say that f is continuous at a point x equal a if the limit when x tends to a of f of x هي f of a. الفكرة إنه if you make small changes on the input, you get small changes on the output. Okay, so small changes on the input gives you small changes on the output. Okay, this is the continuity. Means that your function is somehow stable. Okay, the error doesn't spread. Okay. So the same idea for a function of multivariables. So here, if you have two variables, so an ordered pair, so here x, y. So we say that a function is continuous at a point AB, where A is the value of the first component x and B is the value of the second component y, if the limit the multivariate function f of the two variable xy when the point xy tends to the point AB is nothing else than the value of the function at this point. Okay, this is continuity at the point AB. The point continuity on the domain D, we say that f is continuous on the domain D if it is continuous at every point of this domain. Okay, so the idea, the meaning of continuity is that if we have small changes on the input, we get also small changes on the output. Okay, and this is very, very important in practice. Okay, because in real life application, all our data are approximated data, or even in rare cases where we have exact data, we use numerical methods, we use computers for computing the solution, so we make error. So we have to be sure that this error stay controlled. Okay, we can control this error. And graphically, this means that if we plot the graph of the function, so the surface that is the graph of a continuous function has no hole, no breaks. Okay, it's quite smooth. Okay, so this is C0. This is the lowest level of smoothness which we expect on a function. Okay, of course we deal with which are discontinuous, but in this case it needs very, very special care and very sophisticated mathematics. So كل ما كانت الفانكشن smooth enough كل ما سهلت علينا, as we said, the prediction of the behavior of this function. So this is the definition of the continuity of a function on a point, that the limit of this function when the input is close tends to AB, it's just the output associated to this pair AB. This is the definition. So in particular, so the sum of continuous function are continuous, the difference, the product of continuous function are continuous, the division of continuous function are continuous except on points where the denominator is not zero. So as a consequence, on the classical functions we are dealing with, for example, for polynomials, we have no problems. Polynomials are continuous on Rn, where n is the number of variables. So if you have two variables, your polynomial will be continuous on R2, three variables on R3, and so on. So the rational functions of polynomial over polynomial are also continuous on the domain, no more on Rn, because here, so P1 over P2, so the domain, you have to be sure that P2 of your input is different from 0 to be defined. Okay, so this is continuous on its domain, not on the whole space Rn. So, for example, we are asked, and when we know that a function is continuous, the calculation of limit becomes very, very easy because, as in this example, this function is a polynomial. It's a polynomial function of two variables, f of x, y. So this is a polynomial. A polynomial is continuous on Rn. So here we have just to calculate the output associated to this point 1, 2 here. Since we know that the function is continuous, so we have just to replace x by 1 and y by 2 to find the limit. Result is you just calculated 8 minus 4 plus 3 plus 4. It's 11. So the limit of this function of the point 1, 2 is 11. Since it's continuous, we have just to replace to determine the output associated to this point. Now the question, we are given a function and we are asked to determine where this function is continuous. So this function is called a rational function. And the rational function, we know that it is continuous on its domain, on D. So this function is a rational function. A rational function is continuous on its domain. So we have just to determine the domain of this function, and we get also the domain of continuity of this function. So this function, where this function is defined, how can we determine the domain of this function f? So under which condition this function is defined? وين عندنا مشكلة؟
x تربيع زائد y تربيع equal 0.
No division by 0.
No
is
division
allowed.
by 0.
So f defined f x squared plus y squared equal 0. And since this is the sum of two squares, the sum of two non-negative numbers, so this sum is 0 only and only if x squared is 0 and y squared is 0. So the domain of f is the set of ordered pair xy, two variables, in R2 because we have two variables, such that xy is different from the origin 0, 0. So we have only a problem at one point, x equals 0 and y equals 0. Okay, so you can write it as the whole plane R2 except the point 0, 0. This is the domain of this function. So where this function is continuous, it is continuous on df, also R2, except the point 0, 0. So if you want, the domain of continuity is the domain of definition. If you call this domain of continuity of f, it is the same as the domain of definition of f for this for rational functions. This is the idea. This is if we take the same function. So قلنا this function is undefined at 0, 0 and not continuous at this point. So usually people, what do they do? Sometimes they extend this function, okay, by defining a new function. So هذه f اللي شفناها in example 6. قلنا definite and continuous. For x, y different from 0, 0. If we define a new function, g, which is somehow an extension of f. We extend f by giving value here at 0, 0. So we are defining g of 0, 0 is 0 here, for example, or it can take any value, okay? To obtain a function which is here. So now the domain of g is R2 كامل. Okay, can the domain of f is R2 except 0, 0. حلينا مشكلة 0, 0 إنه we extended the function f, define a new function g by giving a value of this function for this function at 0, 0. Okay, so this function have different expression depending on whether the input is 0, 0 or not. Okay, some you have piecewise defined function. Piecewise defined function. So the question, so now this function is defined on R2. السؤال, is it continuous on R2? Is it continuous at 0, 0? Okay, so we have to study the continuity مستمرة of G, no holes, no breaks at 0, 0. This is the question. If it's continuous at 0, 0, it will be continuous everywhere because it's already continuous at all R2 except at 0, 0. المشكلة الوحيدة بقت في ال 0, 0. How to study the continuity of G at 0, 0? What should we show to be sure that we have continuity at 0, 0? To do this, to answer to this question, we have to show that limit g of xy when xy tends for 0, 0 لما نقترب من 0, 0 the output يقترب من g of 0, 0. This is what we have to show to prove continuity at this point. وكم قيمة g of 0, 0 هنا؟ g of 0, 0 هي هذه. So we have to show that the limit of this function g at 0 0 equals 0. Okay. هذه أتوقع شفناها x square minus y square over x square plus y square في limits. Yes, in example 1, we have already calculated the limit of this function at 0 0. قلنا it doesn't exist. قلنا this limit, unfortunately, it doesn't exist. So what can we conclude? هل this new function, this extension, is continuous or not? قلنا unfortunately, the limit
not continuous دكتور.
not continuous because the limit at 0 0 of gxy اللي هي the limit xy at 0 0 of x square minus y square over x square plus y square. قلنا هذه we have already studied this limit in example 1. We call this limit does not exist. So it cannot be equal to g0 0. Okay, so even we extended the function f by giving a value at 0 0, symptotic value من عنا, it doesn't match. So the following function is g is discontinuous at 0 0. مو لأن أعطيناها قيمة صفر، حتى أعطيناها أي قيمة 5 7 9 مش راح تضبط. You know, this limit does not exist. So we cannot extend the function f by continuity. So in this case, we fail to extend this function by continuity since this limit does not exist. So no hope to get an extension which is continuous at this point. This example. So this example also, so here we have troubles at 0 0, so we cannot define it at 0 0. So we extend the function given a new value 0. هنا 0 بالحظ راهو كلهم اعطوا قيمه 0 لكن كانوا ممكن يعطيوا اي قيمه. اوكي، الهدف انه هل we obtain a continuous function by this way or not. Again, we have to calculate the limit here at 0 0. At 0 0 of 3x square y over x square plus y square. هل حسبناها هذه 3x square y plus x over x square plus y square? Did we calculate this limit before 3x square y? Yes, it's example 4. It's example 4 and example 4 قلنا this limit exists and it's equal to 0. So this limit already calculated in example 4. So this is example 4. It is equals to 0. So is it equal to f of 0 0? Sure, icon. And the limit equals f of 0 0. Yes or no?
No, because it's not possible to have 0 0 in denominator.
Okay. Your answer is wrong. The answer is yes. It is equal to f of 0 0. Mean f of 0 0 هي هذه. We don't use this expression, we use this expression. Okay? قلنا this function has different expressions depending on the value of the input. هذه نستخدمها فقط لما xy not 0 0. At 0 0 we use this value. So yes, the limit at 0 0 equals the value of the function at 0 0. So we can say that f is continuous on R2.
يعني أن كل ما الليمت قرب إلى صفر من naturally
not قرب إلى صفر. هنا هذا صفر بالحظ، لكن ممكن يكون أي قيمة، المهم يقرب من الأوتبوت at this point.
yeah.
Okay, so 0 is here in this example. Okay, فهمت؟ أعطيكم مثال آخر. Imagine you have a function gxy equals 3x square y over x square y square plus 3 if xy different from 0, 0 and 0 if xy equal 0, 0. What do you think about the function g? Is it continuous at 0, 0 at the origin here? Yes or no?
The value would be 3.
Say yes. And I say no here. ليش? What is the limit at 0, 0 of gxy? Here the limit of this part اللي حسبناها هي 0 plus the limit of this اللي هي 3. So the
3.
limit is 3, صح?
Yes.
Is it equal to g of 0, 0?
No.
No, g of 0, 0 is 0 هنا. So here, no. G is not continuous. واضح? To extend by continuity, we don't have to define this function g, but define another function h, for example, اللي هي 3x square y over x square y square plus 3 for xy different from 0, 0, and 3 is xy 0, 0. And these functions are continuous on R2. This function is discontinuous. The extension by continuity to get a continuous function when we have troubles, لازم نختار the extension equal to the limit to get a continuous function, new continuous function. فهمت? And this limit can be 0, can be 3, can be any number. Okay, so here we can extend by 0 because it satisfies the rule. Here, for this example, we cannot extend by 0. We have to extend by 3. Okay, because when xy is close to 0, 0, the output is close to 3, not close to 0. Okay, so it depends on what happens in the neighborhood of this point, close to this point. Okay, so this is the continuity of